check minuses or missings that you have now completed, because that would be important for me to know so that I can change it. I only go fishing for those grades like once a week, maybe every other week, because it's your fault that it's late. So you can take an extra 5 seconds and send me a message and let me know that it's done now. Your mastery work, any questions on progressing to masteries or what you need to do for that? We're all good. So we are now 12/1. Scary enough, it is now December. So, let's use some cards. Yeah. Yeah, it's in that top middle drawer right there. I don't think they're cursed. They're not, like, trying to kill anyone or anything. So, Bella, how would I start this problem? We talked about 2 different methods yesterday. One was definitely easier than the other. How would you start this? Yeah, so the first thing we do, keep the negative 9x plus 15 the same. Then, so we can, but a lot of people seem to not like that process yesterday. So because this is only 1 times the quantity, I think what most people thought was easier was to distribute the negative. And you can do it either way. Both ways will get you there. But that will give us, what's my 2x turn into?
Negative 2x.
Yeah, or like a negative or a minus 2x. And then, yeah, a positive or a plus 1. Any questions on how that negative distributes? Because it was the opposite of a subtraction of 1. The opposite of that minus 1 is a plus 1. This is saying do the opposite of everything in here.
So subtraction sign is actually a negative?
It's both. It's either. They are the same thing. Because this 2x minus 1 is really 2x plus a negative 1. But they wrote it in a cleaner fashion. Make sense?
Yeah.
What about it doesn't make sense? What aren't you understanding? Is it the fact that this is telling you to do the opposite? So the 2x is positive. You're fine with me on that. Subtraction is a made-up thing. Subtraction was made up to represent adding a loss or adding a negative amount. So what this is really doing here is adding a negative 1. But instead of writing add the negative 1, that's kind of dumb because that takes extra work. So they just write minus 1. This tells me do the opposite of that. So the opposite of that, when distributed, that becomes negative, that becomes positive. Abby.
Just to kind of simplify it up for me, is it kind of like 2x and negative 1 kind of in there together, and the negative you can like take out the parentheses and make it a negative 2, but it's mostly minus 2x?
But to take out the parentheses, we have to do the distribution. So I'm going to write this more expanded then. We assume addition between everything. Then the opposite of 2x was negative 2x. We assume addition. The opposite of a minus 1 or a negative 1 is a positive 1. Then I clean this up, and it becomes negative 9x plus 15 minus 2x plus 1. Is he?
Okay, so if you were to like do 9x minus, well, like, okay, so if you're trying to like solve the problem.
Yeah, simplify out.
Yeah, simplify. Would you minus negative 9 minus, or how do you?
So we start identifying our like terms is what you're trying to do.
Yeah.
I have a negative 9x and a negative 2x. If I have a negative 9 and a negative 2, when those come together, I have negative 11. So I have negative 11x. Then I join my constant values, a positive 15 and a positive 1. Because, guys, the sign in front of the term goes with it. It's part of it. So both of those are positive. I just get 16. What do you mean, what? So these join, gives you the negative 11x. These join, give you the 16. But we're at negative 9, told to go down. That's why it gets more negative. Are you confused about the negative 11? This goes back to our first chapter of the year, adding and subtracting positive and negatives. These both have the same sign. Hang on. These both have the same sign, so they keep their sign and they sum together because they're both going the same direction. They're going in the negative. Then it would go the opposite way.
Okay.
Yeah. Any other questions here?
So basically, in the second step, you're just making the right side opposite.
Yeah, we're just making that second parentheses the opposite of what it was.
So, yeah, I'm both confused because you just do, because they're both negatives, if you do like negative 9 minus 2.
That's what we did. But the thing is, when we're at negative 9 and we're told to minus, we go down. Because minus takes me down. So I go down by 2 steps, negative 11. Let's check out this other example so we have like a real problem. My smartboard's all screwed up. It's just like not keeping calibration. So, 2 friends are buying fresh fruit. Jackson buys a watermelon that costs $7.45 and 3 pounds of cherries. They don't know what the cherries cost. The sign fell off. Aaron buys a pineapple for $3.50 and 2 pounds of cherries. Apparently they like cherries. So, using one variable and then constant terms, let's write an expression to represent their total cost. So, let's just go ahead and start by saying their total is going to equal, well, what do we know about Jackson? Hayden, what do we know about Jackson? What's he buy? Yeah, so what's the watermelon cost? So we know what he spent for the watermelon. We don't know what he spent for the cherries. So for Jackson, we can represent that. $7.45 plus 3C or some kind of variable. Then also, so we add, Aaron bought some stuff. Grace, what's Aaron buying?
Aaron buys a pineapple for $3.50.
Yeah, so he spends $3.50 plus 2C, whatever the cherries cost. Now, right now I have that highlighted based on who did what, but now I'm going to use shapes, another way we can model with math, to identify my like terms. What like terms do I have up here, Julia? Yeah, so this C value would be like with, yeah, so if I have a positive 3C and a positive 2C, what do we get? 5C. If I look at my 745, Joe, what is like with that? The 350, they're both positive, I add them together. It's going to give me 10.95. So once we know what the cherries cost, then we can figure out what they spent in total. Yeah. Because that is dollars. We know what it is. It's not a variable amount. It's constant. It represents that watermelon that costs what we know. It's not charged by pound. The cherries, you got to pay per pound, so you need to know that per pound price. Most of the time, watermelons are just, you pay what you pay because they're all relatively close in size. Try the got it for a moment. I want you guys to talk with your partners close by you. How can we figure out an expression for the area of the shaded region? Hang on to it for a moment. I know. I'm going to bring us back in a second. So I have a question for you. And we're not going to discuss the numbers right now. I just want to hear your thoughts. If we're looking for the shaded region here, this is kind of what we mathematicians call a donut problem. You have an object missing the middle. Donut, right? So, how, you don't have to give me numbers or anything, but how can I reason through solving this problem? We haven't talked yet today, Lily.
Okay, so you would have to find the area, or the area of the whole thing, and then you would have to find the area of the unshaded, and then subtract them.
Ooh, so we need to do the whole area minus that middle region. So you guys can get back to work, but that's our thought process that we want to take. All right, is that a question?
So is this just like an unknown value?
So Abby just asked, is this an unknown value or is it just 2 inches? This, we don't know. That's X. This right here is 2 inches, and this right here is 2 inches. This right here is 2 inches. This right here is 2 inches, but we do not know the X. Yep. And then what's your height? Or whatever you want to call it. How much is here? So these spaces make no. This is 2, this is, so those make 4, but then this is X. It's not 2, it's X. So you have 4 and X for the height.
I think first we need ooh, so cheap.
Those look fancy. Sitting on a Home Depot budget.
You gotta ignore it.
You gotta take what you can get.
You gotta take the
Get a blanket. That sounds like a gold ring thing to do. Just put a blanket over top of it.
You gotta paint it.
All right, bring it back together.
Paint it brown.
So,
Paint it brown.
I was back there talking with Justin and Xavier, and Justin made a really good observation about this. What'd you figure out, Justin?
Right, since we have 6 inches for the perimeter of the little square in the middle, we have 2 inches on each side. I just assume that it's 6 inches or 10 inches in total.
Yeah. We know that the width is actually 10 inches because the 6 across the middle span, and then the 2 on the right and the 2 on the left. Now the harder part comes when we have to figure out the height, or whatever you call this. Because remember, dimension names don't really matter. Anthony? Yeah, of course.
So you know the one right, the height, whatever right now is 4 inches.
What do you mean the height right now is 4 inches?
Well, 2 inches and 2 inches and 4 inches.
So you mean the amount of height we know,
Yeah.
but that's not the whole height.
No. So you add that together.
Okay, so that's 4.
And we can assume by looking at how, like, the 2 inches on that the little figure inside is 2 inches tall.
We cannot. You know what assumptions do? They make buildings collapse. They make bridges tear themselves apart,
Like that.
and they make a statement that I can't say in school. But you are not allowed to make assumptions. It makes you look bad. Especially in math, very dangerous.
Like that.
Lily?
Wait, so I did, it would do.
Actually, hold on. Sorry, I'm going to pick on Anthony for a second. Anthony, this distance right here, you said that you were going to assume its length. Is there anything in the diagram that lets me know what it is and not assume?
That's 2 inches. X.
Nothing tells you that this is 2 inches. Move this way. What?
The X inches.
The X is what this represents. So we've got 4 from up here, but how would I represent the whole height?
Plus X.
4 plus X. Okay.
So then if you wanted to find anything, it would be 20 plus 2. I know. But then you would do 2, and then in parentheses you do 4 plus X.
You're solving perimeter. We need to solve area.
Well, once you find it, perimeter,
You can't use perimeter to find area. No. How do we find area? Julia? Ooh, that's volume. So for area, just 2 of them. Just whatever 2 dimensions you have. Length times width, width times height, length times height. Doesn't matter what you call them. Here, I'm actually going to call this length times height. It's 10 long, 4 plus X tall. So guys, please stay with me. My length is 10. My height, might as well put the 4 first, is 4 plus X. Now what do I need to do? Casey, what do I need to do? I have this number, single number, up against these 2 values. How so? That special multiplication, what do we do? Distribute this multiplication. I'm going to divide this a little bit. Did you guys just see that? Ghosts. Yeah, and the arrows all grouped up. So, 10 times 4 gives me 40. 10 times X. If you guys could help me, that would be great. I don't know what you're talking about, but I'm going to hope it's math. So this is my area. Boom, done, 40 plus 10X. But that's the area of the entire thing. Hayden?
When you try to figure out X by doing 10, divide both of them.
This doesn't equal anything except for maybe the letter A because it's the area. This is just an expression. We don't have an equation. We just have an expression. Justin?
Question. Why is it 10x?
10 distributed because we had length of 10 times the height of 4 plus X. So when I go to multiply, I can't just multiply these because this is not one thing. It's 2 things. So I have to do 10 times the 4, gives me 40, and then 10 times the X gives me the 10X. Does that make sense? So we have to distribute the multiplication. We need to, as somebody had said, get rid of that inner box, that inner rectangle. Shane, how do I calculate the area of that inner rectangle? Yeah, my dimensions there are just 6 and X. So the area of the inner rectangle is just X times 6, or 6X. So then how do I calculate the difference between them? Abby, what would I do?
What you would do, find difference between them.
So this was my big area. This was my little area. We want to find the donut.
Don't you want to do 40 plus 10x, which is 50x?
You can't add these.
You can't.
They're not like terms.
Oh, wait.
This is constant. This is variable. You cannot put them together.
Can't you combine like terms for the little area?
Sorry, I think I said that backwards, by the way. This is constant. This is variable. I think I pointed to the wrong one.
So,
But
can't you add 10x and 6? Like,
we could. We can combine them, but if we were trying to find the difference,
oh, wait, you would subtract them.
we subtract them. So really what we do is take your 40 plus 10x, that value, minus the other area of 6x, and we can only combine the like terms of 10x and 6x. When we take that away,
You get 4x. That's how you do it.
so your donuts area would be 40 plus 4x. Once you know what x is, then you can solve for the area. Yeah.
So if you have 4x and you have another 4x, take the 4x from 4x, would you take away the variable?
Yeah, it would totally disappear. So if you have, like, say our variable is water bottles. We're talking about volume, and we don't know how much volume is in here because let's say these are all scratched off. So if you have 4 water bottles full of volume, and then you take away 4 water bottles full of volume, what you have left is nothing of anything. So there's no variables left. There's no, like, you have nothing left.
So if you add something to that 0, would the variable come back?
Depends on what you added to it. If I then added coffee cups, then instead of W, I might have C. Yeah, like, so that changes depending on what we're doing. Yeah, so then if I had like $4, I know what that is. It's $4. Like, it has a quantity, it's countable, it can't change. But if I don't know how much is inside of this, it's a variable. Yeah. Thank you. You have really good questions. Appreciate that. That's the end of the notes, right? Woo! Time start at 7:05. Whoa, come on. Check your attitude. Pass them back, please. Clip 7-4 in your binder. Go ahead and clip 7-4. Spread these out.
Absolute value. Yeah. You need
Pass these back, please.
absolute
It was too short.
Who's doing that? They need some absolute value.
I know.
We need to put that
Pass
sign
these
in
back,
the
please, Zach.
question. Let's make that for discovery.
If you want to make it for me, that'd be great.
We're gonna do it.
You can make the sign like, Abby, you can make the sign something like this doorway is the absolute value or something. Only positive attitudes beyond this point.
Only positive values.
Because we could like hang it from the top. Well, maybe. I don't know about fire code. So, you are classing up your room for Discovery Day. And you decide to buy a painting. Now here's the weird thing. This painting is actually sold based on area. Which, like, the bigger the painting, the more expensive it is. The smaller the painting, the cheaper it is. So you got to calculate the area of the whole thing. Now, they have measured how wide each of them is. And awkwardly, this one's wider than that one. It drives me crazy because they're not symmetric, but we'll move on. You don't know what the height is. We need to calculate the area of the entire painting, all three together. So one of your friends says, hey man, we can calculate the area by doing 6.7h plus 12.4h plus 5.9h. And the other friend says, it's just 25h, man. Who's right? Why, CJ? Why do you think that? So if I look at my 6.7 plus 12.4 plus 5.9, CJ's saying when I add those up, I just get 25, and the H just stays H. Because think about if I slid these paintings together. This distance across the top, like if we don't count this and if we don't count this, would just be the combination of all three, which comes out to be 25. The height of the whole thing would just be your h. So they are both correct.
Correct. Yay! Both of them.
Now, although they're both correct, which one is simpler? Xavier? Why?
Because it's like you don't have to add up anything.
Yeah, there's less, right? It's simpler because there's less. So, even though they're both correct, the 25h is probably better because it's simpler. It's already been simplified. They've already done the addition. And the less work that you have to do, the better it is.
Yay.
I agree with you guys. I'm not trying to give you work. I'm trying to make your life better.
He loves us very
Exactly. That's like, I don't like get joy out of seeing you guys work. I get joy out of seeing you guys learn.
and having absolute right.
So, we, actually I'm going to skip this for now. This problem, I've realized, we'll come back to this. Maybe we'll wait till tomorrow for it. So let's look at this one. I want to write an expression that's equivalent to this expression as the difference of two products. So what does it mean to have a product? Either of you. Yeah, the thing multiplied. Whatever has been multiplied, that's your product. So 6 is a product if you look at it as 2 times 3. 5x is a product because it's 5 times x. So we want to write this, well, what's a difference? What kind of problem is a difference problem? Andrew?
Where you subtract.
Yeah, so we could go ahead and set up, we're going to have something subtracted by something. This is going to need to be a product, and this is going to need to be a product. Justin now, since Xavier stole the last one. Xavier?
Is it 5x and 2y?
Ooh, so we can do 5x, and then minus, but if I put 2y here, where's the 11? So we can go ahead and put the 11 in here, but do we make it plus 11 or minus 11? This is going to apply to everything over here. You're absolutely correct. This would be plus. Because when that distributes, that would become minus 2y, and this would become minus 11. Now, we could have actually made this even more complicated if we want to.
Please don't.
Oh, well, you don't have to, but I'm going to. We could have made this something like 5x plus 20 minus 2y. Well, now, what would I need to subtract from 20 to get down to negative 11? I just threw it in there as a constant value. Hayden? Yeah, I just threw it. So what I'm trying to get you to see is how this value would change if I had a constant value as part of my first one. Justin?
31.
If I do 31 here, 20 minus the 31 would get you to negative 11. I could actually write this a million different ways, like infinitely many different ways. I could keep changing my constant values. I could actually throw a bigger x value here and then have some x values here that get taken away. Like we could literally write this infinitely many ways. That's the thing about equivalent expressions. So now we're looking at putting up a new fence, and this is like identical to what I've been trying to convince my brother to do. I might honestly buy him a section of fence for Christmas. So he has a shed that we built in the corner of his yard.
Good morning, Ashley DeVillers. Please come to the office. Ashley DeVillers to the office, please. Thank you.
So where that shed is, we wouldn't need to put a fence if we put the fence like right up against the shed, because you're just trying to keep your dog in or whatever. You could butt the fence against the shed. Here, we're visualizing it with a doghouse, but in my situation, there's honestly a shed in the corner. So we need the fence that does the rest of this side and the rest of this side, and then all of this side and all of this side. So the question that we got to answer first is, what is this length and what is this length? Or width or height or whatever you want to call it. So, Michaela, if you look at my span across the top and compare that to the span across the bottom, what parts are involved in this whole distance? So relate that your top will be the same as the bottom. So what parts are involved in the bottom? Check it out. What parts are involved? We've got two different pieces. So what's the part that we know? You looking at the right notes? So when we look at the top being the same as the bottom, you guys can be solving this on your own. You're always able to work on your own. When we look at this span distance, it's going to be the same as this span distance. So we know a section, and we know an x. So we want to just add those together. Be careful. We don't want to do too much that we're not focused.
Wait, I have a question.
So if we break this apart right here, on the left side of that, I've got a constant value, and I'm going to go ahead and just use a decimal of 6.5. On the right side of that, I've got a distance of x. Maylee, what about the height or whatever dimension you want to call this? We also have multiple pieces. So if we relate that this is the same as this, what pieces are involved? Yeah, we've got 4 1/4, which I can write as a decimal as 4.25, and x. So now to calculate the perimeter. Justin, question or comment? Okay. 6.5 is a value that we know. X is a value we don't know. Not like terms. Can't add them together because they're not like terms. Thank you for asking. This is constant term. This is variable term. Can't be added. Xavier? We can add both constants together. So let's walk around the fence. Obviously not really. But if we want to start talking about the perimeter, we're going to P equals down here. And let's start walking right at the doghouse. As I start going this direction, how far did I go? Anybody? X, right? So start with, we have an X. As I walk across the top, how far did I go? Ooh, not 6.5x, 6.5 plus x. Be careful about that addition in there. Then, as we walk down the fence, we went 4.25 and another x. And then, as we go back to the doghouse, we walk another x. Now, with shapes or colors or however you do it on your paper, let's identify the like terms. X. What else goes with x, Jack? Okay, which? Like, so then this x. And then the next x. And then the last x. So how many x's do we have now? 4. So we have 4x. Then, what are my other like terms, Miss Cannon? 6.5 and 4.25, which gives me an astounding 10.75.
Astounding.
So once I know how long he wants those x dimensions to be, I can figure out the total length of the fence. But until I know those x dimensions, I'm stuck.
So, my question is, is the reason why it's 4x not only because there's 4 x's, isn't that just because you need to make the x's into some sort of like value?
So this still doesn't have a value. It's still unknown. What I know is it's 4 times the unknown value. So the reason that we have 4x's is think about going for that walk. I walked x distance. Then I walked 6.5. Then I walked x. Then I walked x. Then I walked 4.25. Then I walked another x. So by the time I've gotten back, I've walked 4 x's and 10.75. This whole thing would have the label of feet.
Okay, that makes more sense.
CJ? It's around everything but the doghouse. So there would be like a door. Like there would be a door right here. Or this could be open. Like if I build my dogs a doghouse, I'm going to have one side totally open. Like no door, like just open. So that's called an Adirondack. An Adirondack shelter is a 3-sided, and actually they have Adirondack chairs too. You sit in it, arm, 3-sided. So an Adirondack shelter has a back and 2 sides, but the front's totally open. And they're dogs. They're huskies. They won't freeze. Questions? So tomorrow we will wrap up this chapter and probably do a little bit of review. I will take any questions, because guys, I only had like 2 texts about homework last night. I will take any questions once we wrap the lesson tomorrow. So anything from the homework, bring your questions with you. Yeah, there's one question that has 2 identical answers, but they're both marked right. Oh yeah.
Tell you at the phone calculator poster too.